Now the halogenation. Aromatic halogenation, that is chlorination and bromination, is generally brought about by treating the aromatic compound with halogen in cold, dark and in presence of a strong Lewis acid, the halogen carrier, like iron, iodine, ferric halide or aluminum halide. The usual practice is that some iron fillings are added to the reaction mixture, the aromatic compound plus halogen. When iron fillings are converted by the halogen into the corresponding ferric halide, the reaction is C6H6 plus Cl2 in presence of AlCl3, it gives C6H5Cl plus HCl, the chlorobenzene. Here the mechanism applied is the three common steps of the reaction is A. Formation of electrophile. The metallic halide Lewis acid polarizes the halogen molecule to give the electrophile X plus, the halonium ion. For example, FeCl3 plus Cl2, it gives FeCl4 minus plus chloronium ion. The formation of carbocation, the formation of final product. Similarly, benzene undergoes bromination but slower than chlorination when it is treated with bromine in presence of ferric chloride. Since the reaction between benzene and fluorine is very vigorous, direct fluorination of arene is not possible. C6H6 plus 3F2, it gives 6HF plus 6C. Now, since hydroiodic acid Hi is a strong reducing agent, it will reduce iodobenzene formed by the iodination to benzene. Iodination should be carried out in presence of an oxidizing agent like iodic acid, nitric acid or mercuric oxide. The reaction is C6H6 plus I2, it gives C6H5I plus Hi, where the hydroiodic acid reacts with Hi, the Hi plus HiO3, it gives 3I2 plus 3H2O, or the reaction is C6H6 plus 5I2 plus HiO3, the 5C6H6, it gives the 5C6H5I plus 3I2 plus 3H2O. With excess of chlorine in presence of anhydrous AlCl3, the catalyst, and dark, all the hydrogen atoms of benzene ring may be successively replaced. The reaction is C6H6 plus 6Cl2, it gives C6Cl6 hexachlorobenzene plus 6HCl. The next, halogenation of homologous of benzene. Homologous of benzene, that is toluene, may undergo two different types of chlorination or bromination, like nuclear and side chain. Nuclear chlorination or bromination. Nuclear chlorination or bromination is achieved by cold, dark and in presence of the halogen carrier. The reaction is toluene plus Cl2 in presence of iron. In dark it gives orthochlorotoluene and parachlorotoluene. On the other hand, side chain chlorination or bromination is favored by high temperature, light and in absence of halogen carrier. Therefore, the chlorine is passed through boiling toluene solution in presence of sunlight. Substitution takes place in the side chain. Toluene plus Cl2, it gives benzyl chloride, which further reacts with chlorine to give benzyl chloride, which further reacts with chlorine to give benzo trichloride. Remember that the nuclear halogenation takes place through ionic mechanism, while the side chain substitution takes place through the free radical mechanism. The side chain halogenation is of abstraction of halogen atoms follows the allylic, which is more or less equivalent to benzylic, then the third degree, then the 2 degree, then the 1 degree, then the vinylic. Therefore, the chlorination of ethyl benzene forms mainly 1-chloro 1-phenyl ethane. The reaction is ethyl benzene plus Cl2, heat or light, it gives 1-chloro 1-phenyl ethane, which is 90%, and 2-chloro 1-phenyl ethane, which is 10%. Sulfonation is brought about by the action of concentrated sulfuric acid. Now next, sulfonation. Sulfonation is brought about by the action of concentrated sulfuric acid. The benzene plus H2SO4 at 80 degree centigrade temperature, it gives the benzene sulfonic acid along with the liberation of water molecule. Sulfonation can also be carried out at room temperature with concentrated sulfuric acid in presence of BF3, boron trifluoride, as catalyst. The mechanism. The reaction mechanism involves the following steps. A. the formation of electrophile. Here the electrophile is sulfur trioxide, which is neutral, or SO3H plus, which are produced by the dissociation of sulfuric acid. Here the two molecules of sulfuric acid, it dissociates to give SO3 plus H3O plus HSO4 minus. The SO3 plus H3O plus, it gives the SO3H plus H2O. The electrophilic character of SO3 is due to the presence of electron deficient sulfur atom, as is obvious from the structure of its molecule. Sulfur has 6 electrons. The formation of carbocation. Slow step. The transfer of proton to form the resonance stabilized sulfonic acid anion. This is a fast step. It gives the benzene sulfonic acid anion. Next, the reaction between sulfonic acid anion and the hydronium ion to form the final product. The equilibrium of this reaction lies to left. Sulfonation of benzene with oleum, the concentrated sulfuric acid and sulfur trioxide at high temperature, gives metabenzene